Okay, now we're going to take a look. This is video 3. We're going to take a look at the human impacts on the atmosphere and vice versa. Take a look at air pollution. I'm using Dr. E's PowerPoint again. This is a really awesome PowerPoint. It has tons of information. I'm going to go through it really fast. I'll tell you guys flat out, I expect you guys to pause this and summarize this information because there's such a huge amount of information in this, and it literally is all just memorizing and being familiar with the different characteristics. So I'll tell you, or I'll give you suggestions as to how I would organize it to help you guys to learn this stuff as we go through. So there's some of the stuff that we're going to fly through because it's literally just all there. It's not anything that you guys would have difficulty understanding, I don't think. So air pollution. The term smog was first used in 1905 to describe sulfur dioxide emissions. This is where we start to get the concept of air pollution coming in, the concept that air could be polluted, there could be something wrong with our air. 1952, severe pollution took the lives of 5,000 people in London. Right after the war, huge industrial jumps, so on and so forth, and nobody was monitoring it. That doesn't mean that it isn't new to, it isn't a recent thing. There have been, air pollution problems for hundreds of years. It's just that it is getting significantly worse, or has gotten significantly worse. So it's not the, you see that quote is a very famous quote. It isn't pollution that's harming the environment. It's the impurities in our air and water that are doing it. Okay, so the Clean Air Act. Congress found that most people are living in urban areas. It makes sense. Rural is pretty much outdated. There's not that much happening as much anymore. More and more people are living in cities or towns. That industrial growth results in air pollution, and then air pollution is an endangerment to living organisms. What the Clean Air Act decided was that prevention and control was appropriate, had to be at the source of the pollution. That the efforts, the people responsible for that is at the state and local level, not necessarily the federal level, but that federal funds and leadership have to be employed in order to make effective programs, so that the federal government and leadership will develop programs that then are implemented at the state and local level. It was signed in 1963. The states controlled the standards. In 1970, the federal government decided that state control of the standards was not such a great thing, so they set out uniform standards so that there can be only X amount of this chemical and X amount of that chemical in our air. The pollutants, the criteria, looked at a human health risk primarily, and then the secondary pollutant looked at crops, animals, climate, personal comfort, materials, all the extra stuff. So put our human health first, and then everything else second. In 1990, it was updated to look at acid rain, smog, toxins, ozone, and then marketing, and then the VOCs. All those are things we're going to be talking about. In 1997, we reduced the ambient ozone levels. This is costing about $15 per year, but it's also saving 15,000 lives every year. Bronchitis has been reduced by about 60,000 a year, and hospital respiratory problems have been reduced by about 9,000 a year. So we are seeing improvements. This Clean Air Act has been a huge help in that primary thing. Okay, so outdoor air pollution is the first thing. The major sources, stationary or mobile. Stationary is the combustion of fuels like power plants, wood burning, crop burning, forest fires, industrial commercial processes, solvents and aerosols. I mean, this is common sense, guys. Where does air pollution come from? What are we putting into our air right now? You guys can list off like 10 different places probably from the top of your head just around here. Mobile sources are stuff that's not stuck in one place. It's moving: cars, trucks, buses, motorcycles, RVs, boats, trains, farm equipment, construction, all of those cases. So, exactly stationary or mobile, you guys could list off a whole bunch of sources for each, I'm sure. So we look at that. We look at accidental versus purposeful releases or controlled emission releases. For example, we know that like cars and power plants will release X amount into the atmosphere, and that's very well controlled, versus the accidental releases, a spill or something like that, or a forest fire, that is not controlled. So 50% is from mobile sources. And then the other two, the major sources and the area sources. Okay, so human impact on the atmosphere. We burn fossil fuels, we use fertilizers, we refine petroleum, we manufacture a whole bunch of stuff. So these are all of our actions. This is what we're doing, and this is the impact. Okay, so it adds carbon dioxide and ozone, increases global warming and climate change, it produces acid rain, it releases nitrates, continue. So look at those two columns, that's what that is looking at. Okay, EPA uses 6 criteria, Environmental Protection Agency, by the way, 6 criteria pollutants as indicators of air quality. We're looking at nitrogen dioxide, ozone, carbon monoxide, lead, particulate matter, sulfur dioxide, and VOCs, which are volatile organic compounds. EPA established for each concentrations that are allowed in any particular area, and at which point we're going to hit adverse, where are we going to hit problems if there's this amount or higher in the air. Okay, so this is what I'm talking about that I'm going to flip through really fast because this is literally just memorization, guys. So for all 6 of these, there's a slide for all 6. Make sure you go through. What I would do is make a table for this. That would be what would help me the most, or maybe flashcards. So I know the properties, the effects, the sources, and the EPA standard. I wouldn't stress about memorizing that particular one, but I would know the order of magnitude, like how much parts per million, right? A very, very small magnitude, a very, very small magnitude allowed in the environment, in the air right now. So go through for nitrogen dioxide, and then it's going to give you sources of those. So it talks about sources here, but it gives you examples, how much from each source is coming through. To summarize, the ozone, same thing. Okay, for this one, we know that this is much more dangerous to humans. It gives you where the sources are coming from, what percentages. Carbon monoxide, same thing. Notice this has a much higher EPA standard. There's more allowable in the air. Same thing. Okay, lead, incredibly small amount in the atmosphere. Micrograms, so keep that in mind. Look at those orders of magnitude. Suspended particulate matter, again, very small. Sulfur dioxide, a larger percentage allowed. And the VOCs, this says 600 million tons of CFCs, chlorofluorocarbons. Sorry, I'll spit it out in a minute. So you can look at those. So like I said, make up that graph. This is pretty much what I'm talking about right here. You might also want to include the percentage, how much you can have in the atmosphere, something like that. But this pretty much sums it up. So you can pause all of those and talk about it. Other air pollutants are listed here. I would just make sure I recognize these. If you can give, 4 or 5, I would be able to give 4 or 5 examples, specific examples, off the top of your head of air pollutants, and make sure they're those top 6 first, and then, be familiar with these, recognize them as a pollutant, but not necessarily memorize them. Okay, so the formation, how does air pollution form? How strong is it? The factors that affect that is exactly what you would expect. The climate, the topography, population, industry, all the stuff that we are doing, and what is going on with the environment and the air around us, the weather around us, all of that's going to affect how much air pollution you see at any given location. So smog forms when polluted air is stagnant, it's not moving. So that's the weather conditions, the geographic location. If there's no wind moving through, every still day, you see a whole lot more smog that happens in Houston. Not very often, but it does happen. Diagram of summarizing exactly what I've been talking about, the primary versus the secondary pollutants, and then from your sources, a natural source like a volcano, a stationary source like a power plant, and a mobile source like a car. So pretty self-explanatory. Photochemical smog is coming from mixing in with the sunlight, essentially. So you have the primary pollutants, combining UV radiation into that and then ending up with nitric acid and ozone, which is a photochemical, which is a little bit different chemical compound than you would see originally. Okay, calm winds, like I said, the weather is the big factor. If it's not very windy, if there's not a lot of air movement, not a lot of breeze, then that's going to trap a whole lot of that pollution in one place. Okay, so results. This is looking at the national standard and how we are doing with that comparatively. So you can see we're really doing pretty good overall. With time, most of these are going, all of them are going down. Ozone is the only one that is really a big problem still. And that's, you know, depending on where you are. Some places are a whole lot worse than others. So you see trends, you can look at this and talk about this. Notice that in Beijing, their blue sky is going up, that's good. Their concentration chemicals is going down, also good. But notice that they're still above the level, the ambient air quality standard. So they're still working on stuff. Indoor air pollution, why is it important? 70-90% of the time we spend is inside. In our house, where the significant pollution sources, like the paint, glue, stovetops. So most of our exposure is driven by the indoor exposure because we spend most of our time inside. Obviously, the more susceptible groups, the old and the very young and the sick, are more susceptible to that. So this compares looking at, you know, in different places, how much time is spent inside versus outside. Obviously, the U.S., we're mostly inside, unfortunately. Okay. The Inquiry on Indoor Air Pollution in 1991, I'll let you guys read through that. House of Commons Inquiry. Indoor air pollutants, again, make sure that you recognize these, make sure that you go through and understand them, can name a few maybe. It's all self-explanatory. Same list. Okay, so the health effects. Again, this is what I meant. Again, make another slide. I'm going to flip through this super fast so this video doesn't take 10 hours for you guys to watch. But it's going to go through all the different health effects. Know what chemical. Okay, so we've got a chemical. Know where it impacts. The strength, perhaps, where it comes from in the house. Make a table summarizing this information because it's going to be the same type of information on every slide. So you have it for nitrogen dioxide, carbon monoxide, formaldehyde, the VOCs, dust mites, fungi and bacteria, tobacco smoke, fine particles, radon, and then this is summarizing because radon is a big risk. So this is showing you just how at risk you may be, so you guys can figure out, you know, how risk, where you are in this table. Continuing on with that, so radon, and as you can see, it's really important because most of our exposure to air pollution comes from radon, so it's one of the big ones we need to watch. Radon zones. So we're doing in Texas, if you're looking at this, you see zone 1, 2, and 3. Zone 1 has a greater than 4 concentration. Zone 2 is 2 to 4, and Zone 3 has less than 2. So we're down in Zone 3, which is really good. So you can see where, you know, you're noticing a lot upper in the northern areas, maybe where their heating comes in from heat sources. Okay, how it enters buildings. A lot on radon because it's so absolutely important. So make sure you guys are understanding radon. Make sure you go through, look at how it enters the buildings, look at how it, what it looks like, what it contains, what it can cause. I'm going backwards now, just in case I'm freaking you guys out. What it can cause, lung cancer most especially. So this is a cancer thing, which is why it's such a big deal. 'Very, very simple solutions. So the sick building syndrome versus the building-related illness all comes from air pollution. The sick building syndrome is a persistent set of symptoms over 20% of the population. So that whole building, there's something in that building that's making you sick. But we can't figure out what it is, we're not recognized, and then you get better when you leave the building. Could be anything, any of those symptoms, just something in general is not feeling right. Building-related illness is a clinically recognized disease exposure to indoor air pollutants from recognizable causes. So the sick building syndrome, you can't recognize the cause. There's something in the building that's bothering a lot of people, but we don't really know what it is, so we can't put a stop to it. From the building-related illness, we can recognize what it is, so we can put a stop to it. And then the diseases that are recognized, Legionella is a bacteria, an airborne bacteria, so it's Legionnaire's disease. The hypersensitivity, pneumonitis, humidifier fever, asthma, allergy, respiratory diseases, all of those are caused by different pollutants in indoor air. Okay, and we are stopping there. So that was super fast, guys. Go through, please, and make sure that if you don't understand this stuff, please, let's talk about it. We'll try to summarize and check those charts and everything, talk about them when we are in